I will be presenting on the topic of highway maintenance, pavement stresses, maintenance types, and drainage importance. This topic is in the field of transportation engineering as it ensures road safety, serviceability, and durability. Over time, we will explore types of pavement distresses, their causes, different maintenance strategies, and the often overlooked yet vital role of drainage system in pavement health. Next slide. Introduction. What is highway maintenance? Highway maintenance is the systematic activities aimed at preserving pavement integrity, ensuring safety, and maintaining ride quality by addressing damage and managing ongoing wear. Uh, Highway maintenance refers to all the activities carried out to preserve and restore a road to its original or acceptable conditions. It plays a crucial role in preventing failures, reducing repairs cost, and improving the driving experience. The importance of pavement maintenance is the crucial for preserving infrastructure, minimizing repair cost, and sustaining smooth traffic flow by preventing further pavement deterioration. These are three topics we will cover in this presentation. First is common pavement distress and distresses, various maintenance of strategies, and the essential role of drainage. The example is the think about a typical monsoon in Mumbai. Roads that are not properly maintained quickly develop potholes, leading to accidents and traffic delays. Next slide. Pavement distresses. Definition. The definition of this pavement distresses is pavement distress refers to visible signs of deterioration or damage on road surfaces, impacting functionality and safety. Second is the types of pavement structures. Flexible pavement distresses and rigid pavement distresses. Influencing factors: traffic load intensity and frequency, environmental conditions, temperature, moisture, material properties and construction quality, effectiveness or of drainage. Pavement distress refers to visible signs of deterioration and that indicate the pavement is no longer performed as intended. Next slide. Common flexible pavement distresses. Cracking types. There are three cracking types: alligator cracking, alligator cracking, interconnected uh, cracks that resemble a reptile skin, typically from repeated traffic loading. A pattern of small connected cracks that looks like an alligator skin. Longitudinal crackings, cracks running along the road in the same direction as the traffic. Transverse cracking, cracks running across the road at right angles to traffic. On NH48, especially near industrial zones, overloaded trucks caused severe routing and fatigue cracking over time due to repeated stress. These are the example of this flexible pavement distresses. Other distresses is routing deep grooves on into the road where vehicle wheels pass. Potholes, small holes caused by pavement breaking down. Rivaling, surface wearing away due to loss of small stones or binding materials. Next slide. Causes of flexible pavement distresses. Heavy traffic loads, poor construction, water infiltration, and environmental factors. Heavy traffic loads, repeated loading from heavy vehicles applies stress beyond the pavement's design capacity. This leads to fatigue cracking, deformation, and eventually failure of the pavement layers. Over time, the cumulative effect compromises structural integrity, reduces ride quality. Poor construction, inadequate compaction, and improper selection of materials during construction weaken the pavement structures. These deficiencies cause uneven support, premature surface, cracking, and early onset of distresses that shorten pavement service life. In water infiltrations, water penetration through cracks or joints saturates the base and subgrade layers, reducing their strength and stiffness. This weakens the overall pavement structure and accelerates deterioration, erosion, potholes, formation, and loss of support. Environmental factors. Thermal fluctuation cause expansion cycles in pavement materials. Cracking and exacerbate materials fatigue. This is with extreme seasonal temperature change. Roads in Kerala, in example, roads in Kerala's coastal belt face frequent potholes formation after heavy rainfall due to water stagnation and weak subgrade condition. This is a direct result of poor drainage design. Friction pavement distresses. First, cracking, faulting, spalling, blobs. In cracking, encompasses corner, longitudinal and transverse cracks caused by traces and subgrade issues. Second is the faulting, vertical displacement occurring near joints that result in uneven pavement surfaces. Spalling, surface chipping or flaking often caused by freeze-thaw cycles or improper finishing techniques. Blobs, sudden upward heaving of pavement slabs due to thermal expansion in slabs with insufficient pore jointing. In example, a section of Delhi Ring Road experienced a blow due to extreme summer heat, where the concrete expanded beyond its relief capacity, causing the slab to buckle. These are images showing the types of rigid pavement distresses: is the block cracking, fatigue cracking, delamination, swelling, edge fatigue crack, corrugation, longitudinal crack at joints, bleeding, depressions, reflective cracking, edge crack, and etc. In concrete or rigid pavements, experience different types of failures. In cracking, these types of failures. In faulting cracks, uneven elevation between slabs. Spalling. Spalling is a breaking or chipping at joints. Blobs, caused by thermal expansion in the absence of proper joints. Uh, Common causes of rigid pavement distresses. First is joint failure. Joint failure due to lack of sealant or poor spacing. Means deterioration or improper spacing cause cracks to propagate and lead to faulting. Poor subgrade support. Weak soil conditions result in slab deflection and subsequent cracking under load. Inadequate curing. Insufficient uh, hydration weakens concrete, making it susceptible to cracking and spalling. Fourth, thermal effects. Expansion and contraction induce stresses that cause distress if not properly managed. For example, water seepage into joints caused a long-term corner cracking due to freezing and thawing during winter nights. Classification of highway maintenance types. Routine maintenance in or periodic maintenance. In routine maintenance, preventive activities addressing minor pavement issues to preserve road functions include potholes, patching, crack sealing, drainage upkeeps, debris removal, and minor surface repairs. These actions slow deterioration, maintain integrity, and ensure safety and comfort. In periodic maintenance, scheduled treatments for major pavement repairs and strengthening involves milling, resurfacing asphalt overlays, patching large cracks, full depth repairs, and base reinforcement. These interventions extend pavement life, improve durability, and delay full reconstruction. Effective planning ensures roads stay safe and avoid major repairs. In routine maintenance uh, is the day-to-day Upkeeps involving minor repairs performed continuously or as required. In common tasks, for fill the cracks of a routine or patch, patching potholes and cracks, crack sealing to prevent ingress, shoulder repairs to maintain edge stability. Benefits of this maintenance is cost-effective prevention of deterioration, maintaining safety and ride quality or minor uses. In example, uh, in cold makes asphalt for potholes, patching after every monsoon, though temporarily this ensures safety and traffic flow until proper resurfacing is done. In periodic maintenance, definition of this point is maintenance activities scheduled at regular intervals determined by pavement conditions or time-based cycles. In typical tasks, resurfacing to restore a pavement layer functionality, applying overlays to strengthen the existing structures, and a seal coating to safeguard against moisture intrusion and surface wear. Advantage of this maintenance is reduce the significant deterioration, prolongs pavement lifespan, and decrease total long-term expenses. In example, every periodically schedules resurfacing every 5 years to maintain a smooth ride and reduce fatigue cracking. This extends the pavement's life by decades. In periodic maintenance, is schedule more expensive but prevent structural failure. In routine maintenance, is reactive, done as needed, and is a low cost. Uh, Importance of highway drainage. In infiltration poses a significant threat to pavement durability. Implementing effective drainage is essential for maintaining highway structural integrity, minimizing long-term maintenance cost, and maximizing pavement lifespan. A superior drainage system safeguards the subgrade from weakening, prevent frost have, and mitigate rutting and cracking, thereby preventing accelerated pavement degradation. In drainage plays a key role in the pavement health. Water reduces the strength of base and subgrade layers, leading to uh, premature failure. Improper drainage ensures longer pavement life, reduce need for frequent maintenance, and enhance structural performance. For example, in hilly areas, side drains and longitudinal slopes help in rapid water evacuation, preventing landslides and base erosion. In next slide. In summary, to conclude this presentation, it's recap the key insights. First is types of pavement distress, maintenance strategies, drainage management. In types of pavement distress, water-related issues like frost having, rutting, and cracking can rapidly deteriorate pavement conditions. In maintenance strategies, proactive planned maintenance provides long-term benefits while reactive low-cost repairs are often short-lived. In drainage management, effective surface, subsurface drainage system are essential for preserving pavement integrity and extending uh, its lifespan. Recognizing pavement distress early, whether it's cracking, rutting, or surface wear, is the first step in maintaining road safety and performance. Routine and performance. Routine and periodic maintenance are not alternative but complementary strategies. Routine work handles minor day-to-day issues, while uh, periodic maintenance strengthens the pavement for long-term use. Drainage should never be overlooked. It's not just about preventing water from collecting on the surface. It protects the subgrade, reduces deterioration rates, and extends the life of the pavement. And finally, proactive maintenance is always more economical and efficient than reactive repair. Catching problems early reduces cost, avoids traffic disruption, and ensures a safer travel experience for everyone. Thank you.